Hello everyone and welcome to your first coding lecture. So in this lecture we're going to be learning about numbers and more in Python. And we're going to cover the different types of numbers that we can use in Python, some basic arithmetic using those numbers in Python. We'll also learn about some differences between Python 2 and 3 when it comes to division. And we'll get a quick peek at object assignment in Python. So here I have open the Jupyter or IPython notebook. So you can scroll through this notebook, check it out if you want to go in a little slower at your own pace. There's tons of information here, and we'll be going over all this in this lecture video. Okay, great. So let's just get a quick presentation on the two types of numbers we're going to be working with, which are integers and floating point numbers. So I'll do a quick break to the presentation. Okay, here we are at the presentation now. And there's a lot of different types of numbers in Python, and we're going to focus on two types right now, integers and floating point numbers. So integers are just whole numbers, positive or negative. So for example, 2 and -2 are just examples of integers. And floating point numbers is the other number type we're going to be concerned with right now. So floating point numbers have a decimal point in them, or they can use an exponential e to define the number. So for example, 2.0 or 2.0 there and -2.1 are examples of floating point numbers. Also 4e2, either capital E or lowercase e, is an example of a floating point number in Python. And all that means is 4 times 10 to the power of 2. We'll mainly focus on those 2.0s and 2.1 type of floating point numbers, the one with decimal points in them. Okay, so let's go ahead and hop back to the code. Okay, and we're back to the Jupyter Notebook. And now I'm going to hop over to our live code session. All right, so here I'm just going to be going over the code that we go in the notebook. So let's go ahead and check out how to do some basic arithmetic in Python. Here I have my cell, and for addition, all you do is you type the number in and put in a plus sign, so 2 plus 1. Remember, Shift Enter to run your cells. And there you go, that's how you can do addition. So for example, 2 plus 2, again, just 4. All right, subtraction, it's also pretty simple, just a simple dash sign there. And we can do another example, and 3 minus 2. So right now, when we're first looking into Python, we can go ahead and think of Python as just a calculator. So multiplication, the symbol for that used in Python is an asterisk. So there you have 2 times 2, or 3 times 2 is 6, etc. Okay, so here's where we have to kind of keep close attention as we go into division. And the reason I say that we have to pay close attention is because of the following. So let's say I wanted to do 3 divided by 2. So what would you expect 3 divided by 2 to be? Probably 1.5, right? So if you notice, I'm using Python 2 right now. You can see up here in the right hand corner. And the output is 1. So why did this happen? And if you hop over to the Jupyter Notebook, you'll notice you get a Python 3 alert here. So what's going on? So the reason we're getting this result is because of Python 2. In Python 2 and Python 3, you perform division using this / symbol for division. But the difference is in Python 2, this symbol performs what's known as classic division. And that means that the decimal points are truncated off. So 1.5 gets truncated to 1. In Python 3, however, this single / for division performs what's known as true division. So you would get a 1.5 if you had inputted 3 divided by 2 using Python 3. So what do we do if we're using Python 2 and want to avoid this kind of floating point error? So there's different methods. One method is that you can specify one of the numbers to be that floating point number. So I can say 3.0 divided by 2, and then you'll notice we get out 1.5, the expected result. And that can work for either number. So 3 divided by 2.0. The difference being just one of them has to be defined as a float. Some other things you could do in Python 2 is also cast one of the numbers to be a float. And what casting does is it uses a function that basically turns integers into floats. So what that would look like, and we haven't learned about functions yet, but we'll get a quick sneak peek, is you can call float like this on one of those numbers. So it's float parentheses 3 parentheses divided by 2. And what that's basically doing is it's casting that integer 3 as a float. So if I check what's going on there by itself, I get 3.0. Okay, so there's one other thing that we could possibly do. And again, this is just a kind of a sneak preview because we haven't gone over functions or modules yet. But a really interesting module that Python 2 has is called __future__. And it'll actually allow you to import some capabilities from Python 3 into Python 2. And we'll go over what this is actually doing and how it's working later on in some lectures. But with this line, division, let's see. So right now I've written down from space __, future __, space import division. If I go ahead and run that line, what that's done is it's imported division from this future module. And what that basically does is now it treats division as if it were using Python 3. So you notice I can just say 3 divided by 2, and now that's corrected to 1.5. So let me just reiterate the 3 different things we can do here. You can make sure one of the numbers is a float, or you can actually cast one of the numbers to be a float to make that happen, or you can run this line from __, future __, import division, and that will take care of the rest of the divisions you do throughout Python 2. So my suggestion is running this line. We'll learn later on in lectures about modules and what this is actually doing and how this is working. But right now you can just kind of treat it as this magic line. So if you're ever going to be dealing with division a lot in your code, you want to go ahead and put this at the top if you're using Python 2. Okay, so moving on to some more arithmetic. How about we check out powers? So for instance, 2 to the power of 3. So the way you do that is by doing double asterisks. So 2 ***, the power of 3 is 8. I can say 4 to the power of, let's say 5. That's 1024. And we can also, if we want to do roots that way, so I could say like the square root of 4 is the same as 4 to the power of 1/2, in this case 0.5, and that's the same as the square root of 4. You can also do square roots by importing the math function, but importing the math module, excuse me, but we'll look at that later on in the course. Okay, so moving along, we can also learn about order of operations that are followed in Python. So your standard order of operations are followed. So what I mean by that is if I say 2 plus 10 times 10 plus 3. So order of operations indicates that multiplication has to occur first before addition. So this 10 times 10 is going to happen before the 2 and 3 get added. So Python's not going to follow this reading left to right. It's actually going to follow order of operations. And I can see that occur due to the 105 result we get there. Okay, so what if I want to specify some orders? I can use parentheses, just as you're writing a math equation in perhaps like a TI-83 calculator. So if I wanted that 2 plus 10 to occur first, I can use parentheses to specify my custom orders there. Okay, so that's the basic arithmetic. Let's do a quick overview. Addition is just the plus sign. Subtraction, just that dash, that minus. Multiplication is that asterisk symbol. Division, /. Careful to note that if you're using Python 2, you're not going to perform true division. You're going to perform classic division, unless one of them is a float or you use this from future import division line. Okay. And if you're interested in some more details on that, you can go ahead and read this Python 3 alert in a little more detail in that Jupyter notebook. All right, so moving along, I'm just going to give you a really quick introduction to assigning labels to objects to create variables. So what I mean by that is I can use a single equal sign to assign labels to objects. So to show you an example of this is I can say A is equal to 5. Sorry about that. And so now I've set a label A as a reference to that number 5. So if I call A in my script again anywhere, Python's going to treat it as if it was the number 5. And I can also add those objects together. So I can say, for example, variable A plus A, and it's going to treat it as if it was 5 plus 5. So an interesting thing that we note in Python is what happens if we reassign this label. So if I say now A equals 10. So Python lets it write over. So now if I reference A, it's 10 now. So you can write over those assigned labels on those variables. And we'll go in on the next lecture into a little more detail in case you're jumping in from another language on how Python actually deals with these labels. But for the basics right now, you can just treat it as you choose your variable name, an equal sign, and then whatever object you want to label that. Okay, and you can also use the variable label itself to reassign the variable. So what I mean by that is I can say A equals A plus A. And what Python will do is now it'll say, okay, so A is now equal to A plus A. So what was A originally? Now it was right now 10. So A is not going to be equal to 10 plus 10. So if we check that out, there we have 20. Okay, great. So you might be thinking, okay, so what are the rules on creating these variable names? And there's a couple rules that they have to follow. So I'll jump over here to the Jupyter Notebook where I have them all. Okay, so these names, they cannot start with a number. There can also be no spaces in the name. If you want to specify some spaces, probably use a underscore instead. They can't use any of these symbols right here. All of these symbols are forbidden, and it's usually considered best practice that the names are lowercase. So let's go ahead and go over a super simple example of how we can use these labels and these variables that we make to clean up our code a bit. So these variable names help us keep better track of what's going on in our code. So to give you a small example, I'm going to make a variable called my underscore income. And I'm going to set it equal to the number 100. And then I'm going to make another one called tax rate. Tax underscore rate, and I'll set that equal to 0.1. Great. And so now, finally, I'll say my underscore taxes that I have to pay is going to be equal to my underscore income multiplied by my tax rate. Great. And if I've run that cell, now I've defined my taxes as my income times my tax rate. And if I call it to see what that value is, it's 10. So 100 times 0.1, that 10% tax rate, my taxes are $10. Great. So what have we learned? We've learned some of the basics of numbers in Python. We've also learned how to do arithmetic and use Python as a basic calculator. And we wrapped it up with a quick introduction to variables and how we can create them and label them in Python. So next up, we're going to learn a little bit more of how this variable creation and labeling works. But go ahead and feel free to just mess around with Python. I think one of the best ways to get a quick introduction to Python is just treat it as a calculator. And then with the introduction of variables and labeled names, you'll slowly get more and more complex with your code. But go ahead and mess around with different additions, multiplications, powers, etc., divisions. Make sure you really understand how to do all those operations, because numbers is going to be one of the main building blocks we work off of in our code. So keep in mind the difference between integers and floating point numbers, differences between Python 2 versus 3 when it comes to division, and all the different arithmetic you can use Python for. Okay. So that about sums up our lesson. Remember, there's always more to read in the Jupyter Notebooks if you want to go into a little more detail over anything. All right, guys. Thanks, and I'll see you at the next lecture. Hello everyone, and welcome to the strings coding lecture. So in this lecture we'll be learning about strings. Right now I have opened a live coding notebook, and as always there's an entire corresponding Jupyter notebook for this lecture. For a quick overview of the notebook, it goes over creating strings, printing strings, some differences in printing between Python 2 and 3, string indexing and slicing, string properties, string methods, and then some print formatting issues. So here's what the notebook looks like. You can go ahead and check it out on your own, and everything in this notebook is what we're going to be going over in this lecture. Okay, great. So let's go ahead and just jump right in and get started with some coding. Alright, so strings in Python are used to record usually text information, such as a name. And the way you can create a string is by using single quotes or double quotes in the most basic format. So I can put in a single quote here and then say hello and end it, close it off with another single quote, shift enter to run that cell, and now I have a string there. You can also do an entire phrase like a sentence. So I can say this is also a string, close it off, and you have a string that way as well. Now something important to note in Python is that what Python realizes here is that this string is a sequence, and we'll go over that further in just a little bit. But the way Python is thinking about this string, if you will, is that it's seeing every single letter here as part of a sequence, including the spaces. And when we learn about indexing and slicing strings, that will become a little more clear. Something I also want to note is we've been using single quotes, but we can also use double quotes to create a string. So here I have a double quote, and I can say this is a string, and you can see that works just as well. Now, why would you use double quotes versus single quotes? The reason for that is, let's say you have a string where you wanted to say I'm a string. Now if you notice here, I'm using a single quote in this I'm, so that's going to return an error because of an invalid syntax. So that's one of the instances where you're going to want to use double quotes if you have a single quote within your string. And now that will be fine. And you can also do the opposite. You could, let's say, this is a quote. And you can see that the double quotes are now within this string. Great. So now let's learn about printing a string. So because we're using this Jupyter Notebook setting, if we just run a cell that only has a string in it, it will automatically output the strings. But the correct way to display strings in your code, if you're using idle or another IDE that we've gone over before, is through printing a string. So we can declare a string such as hello world. And let's say we wanted to put in multiple strings. So I say hello world 1 and hello world 2. So if you notice here in this Jupyter Notebook setting, only the last string was displayed. So the correct way to output these strings is using a print statement. And the way that works in Python 2 is by writing the word print space, and then whatever string you want to print. So here again I'll do it, print space, and then the string. So now you'll notice here it's actually printing the string, and these quotes, these single quotes that we saw earlier, have gone away. And this is the main way you want to output or display strings in your code. Alright, some other things to know is that there's special backslash characters we can use in order to print certain things. And what I mean by that is, let's say I wanted to print a new line, such as a space or something. And the way you can do that is by using a \n notation. So I'll show you what that looks like in practice. So I'm going to put a string that says here is a new line, and I'm going to put that \n, and here is the second line. So if you notice, this \n is an indication to Python to not treat this as a regular n, but actually treat this as a new line symbol. And so what that does is it prints out everything until it hits that new line, and then it prints everything else afterwards. So it's able to break up your print statement into multiple lines. Another feature that uses that backslash is T, which stands for tab. So if I run this, it'll actually insert a tab, those like 5 spaces in between where that backslash T was. So that's just something to be aware of. Okay, so if we hop over to the Jupyter Notebook, you'll notice there's a Python 3 alert when it comes to printing. So let's go ahead and take a better look at what that's actually talking about. So Python 3 alerts. There's something to note. If you're using Python 3 versus Python 2, print is a function, not a statement anymore. So if you noticed earlier, we've been printing things with print, space, and then that string. So in Python 2, your print statements are actually going to be print functions, and they're going to look like this. They're going to say print parentheses whatever string you want to print, and then close parentheses. That happens to be a point of confusion because a lot of times you start tutorials that are either in Python 3 or Python 2, and one of the very first assignments you have to do is print hello world, and people get confused based on what version they're using. So you can go ahead and fix this. If you're using Python 2 but want to use the print function, just as before, you can import from the future module. And we'll go over modules later on in the course. But if you want to be printing using Python 3 functions instead of Python 2, you can put this line in your code from __ future _ space import space print _ function, and that will import this functionality into your Python 2. So up next, we're going to be learning about string basics such as length and string indexing. So I won't go ahead and import this. I'll keep using the Python 2 notation, but if you're using Python 3, just keep in mind this is what your print functions are going to look like. And if you're using Python 2, you can import that functionality with that statement. All right, so let's go ahead and move along to some string basics. So we can use a function called len to check the length of a string. So I can say hello world, close it off with single quotes, and then I can put that inside a length function, len. And the way that's going to look is len open parentheses, whatever that string is, close parentheses. And if I run that, it counts the length of the string. So keep in mind, as I said before, the strings are a sequence. So that means that Python can use indexes to call parts of that sequence. And that also means that Python is taking into account that middle space as part of its count. So if you count this here, there's 10 letters, but that space counts as another part of that sequence. So the total count of that length of that string is 11. All right, so let's go ahead and assign a label and create a variable here. So I'm going to say s is equal to hello world. And so now if I call that s either by printing it or just calling s there, s is been assigned hello world. Great. So let's go ahead and start indexing. So indexing uses brackets in Python. So the way this is going to work is I can say s open bracket, the index number, close brackets, and that will return the first element. So something to note in Python is that indexing starts at 0. So like I said before, each of these letters and spaces in this string is part of a sequence. So Python is thinking of this capital H as being in the 0 part of the sequence, E as being in the 1 part of the sequence, 2, 3, 4, so on and so on. So let's say I wanted to get that second letter, which if we're counting from index 0, that's going to be bracket 1, then that can be E there. Great. So we can also perform slicing, and slicing grabs everything up to a designated point. And the syntax for that is using a colon. So I'll show you a quick example. So let's go ahead and grab that S, colon, or whoops, sorry, open bracket, 1, colon, close bracket. So before we actually run this, let's break down what Python's going to say. It's going to say, for this S object, which is hello world, grab everything from that one index, and this colon means onwards. So this will grab everything from 1 all the way to the end. And since indexing starts at 0, that's going to be ELLO space world. And if you notice, something to keep in mind is right now there's no change to that original string. We're just grabbing part of it with this notation. Okay, so you can also say grab everything up to something. So let's say I wanted to grab everything up to the 3rd index. Well, that will give you HEL. So to keep in mind, it's everything up to the 3rd index. So if I look at hello world again, let's just go ahead and show S. That's 0, 1, 2. So if I say colon to 3, that says grab everything, that's what the colon stands for, up to that 3rd index. Remember, it's up to, it doesn't actually include it, which is why we only get 3 letters back. The 0, the 1, and the 2 index. So just to reiterate, here we're telling Python to grab everything from 0 up to 3, not including the 3rd index. So you'll notice this a lot in Python. A lot of the statements and usually a lot of the indexing statements are in the context of up to but not including. Okay, so hopping back to that colon notation, if I wanted to grab everything, then I can just say a colon, and that says grab everything. So something that's really nice about indexing is that we can also go backwards. So if you imagine that this string is almost like a loop, if h is 0, then -1 or 1 backwards would be the last letter or element in that string. So I can say S bracket -1, and that will return D. So that's the last letter. So 1 index behind 0, it loops back around and grabs that D. I can also use that same notation to, let's say, grab everything but the last letter. So I can say grab everything but that last letter there. So that will be hello world without that D at the end. Another thing we can use indexing and slice notation is to grab elements of a sequence by a specified step size. So if you notice right now, the default is 1. But we can use 2 colons in a row and then a number to specify a frequency to grab elements. So what I mean by that is a quick example. I could say, whoops, square brackets, colon, colon. So that means grab everything up to everything. And that 3rd number is going to specify the frequency, so in step size. So right now, this will be everything. So grab everything, that colon, colon, in step sizes of 1. But I could also say go in steps of 2. So I could say colon, colon, step size 2. And now that's pretty much going to grab every other element or letter in that string. And something you can also do is use that same notation to print that string backwards. So I can say grab from the beginning of everything to the end of everything, but your step size is going to be -1. So that's actually telling Python to traverse the string backwards. And it's actually gone and printed out that string in reverse. So this is just a simple notation for reversing a string. These double colon notation methods are not super common, but this reversing of a string is a pretty quick and common way. At least this particular line is pretty common. But these other ones are not super common, but it's important to know them in case you ever find yourself needing them in your code. All right. So let's go ahead and learn about some string properties. Something that's important to note is that strings have a property known as immutability. And the way you spell that is immutability. Immutability. So what this means is that once that string is created, the elements within it can't be changed or replaced. So for example, remember S currently stands for hello world. And let's say you wanted to try to change the first letter to X instead of H. You might think you'd be able to say, hey, that 01, set it equal to X. But if you notice, we get an error. And the type error is string object does not support item assignment. So as you go along in learning Python, these errors are going to be super helpful to find out what you're doing wrong in your code. So something that's always important to remember for strings is that they're immutable. Once it's created, you can't go around changing the particular elements in the sequence. What you can do, though, is concatenate strings together, so you can add on to them. You can't just change what's already there, though. So what I mean by concatenating is, let's say you have S, you can use the plus symbol to concatenate strings together. So I can say S plus, and then let's go ahead and make another string. So I can say concatenate me, which is basically just saying to stick it onto it. And here I have hello world space concatenate me. So while I can't change particular elements in that string, I can add on to it. So that is allowed. And I can also reassign S completely. Just as we saw earlier in some previous lectures, I could say S equals S plus concatenate me. And now if I run that and I check what S is, now S is equal to hello world space concatenate me. Great. Some other arithmetic symbols you can use for strings is the multiplication symbol. So for instance, if I say letter is equal to the string just Z, and then if you notice I call letter as that variable and I get Z, then if I say letter times 10, Python's going to print that letter 10 more times, or 10 times the original amount, whatever it happened to be. So then if I say, let's say letter equals ZZ, print out that letter check, and now I print it 10, so now it's double as many times. Okay, and now we're going to wrap up our method with a quick introduction to built-in strings. Built-in string methods. So objects in Python, they usually have built-in methods, and these methods are basically just functions inside the objects, and we'll go into all that in much more depth later on, but they basically allow us to perform actions or commands on the objects itself. So let's go ahead and create or reassign S again, just to say hello. And here I have S equal to hello. And the syntax for methods on objects is going to be whatever that object label name is, in our case S, dot, and then you call the method on it. So one of the most simple methods for strings is to uppercase a string. And that method is known as upper. Close parentheses there. So basically what this is doing is it's saying, okay, take my string S, that period or decimal point is an indicator that I want to call a method on that object, and then the method I'm using is upper. And I'm going to say close parentheses because I'm not going to add what are called arguments into that method. And so what that does is it basically uppercases that entire string. So the reason we're using Jupyter notebooks, and that's super awesome, is you'll see if I click tab right after that decimal or a period, I get a list of all the different methods I can use on my strings. So if you want, you can go ahead and check out the advanced string lectures, and we'll go over and break down a lot of these different methods that are super useful for strings. Okay, so a couple more methods I want to show you is lower, and I can close parentheses there, and that will lower that string again. So you'll notice here that capital H is now lowercase h. Another thing is I can split a string. So I can say s.theSplit method, close parentheses, and if you notice here, nothing happened. It's returning a list, which we'll learn about in a little bit. But I can say split by a particular element, so I can say split by E, and now you'll notice it's returned a list of that string, but it's split it where that E occurred. So I have H as an element and now LLO as another element in that list. And we'll be going over lists in just a second. Great. So that's about it as far as strings in general. We'll be working with them a ton in Python. So go ahead and review the Jupyter Notebook that goes along with this lecture. Make sure you understand everything. And we'll be recovering and re-going over strings as we move along in the course. Great. And like I said earlier, if you want to learn more about some of these methods, go ahead and check out the Advanced Strings lecture. Okay, thanks, and I'll see you at the next lecture. Hello everyone, and welcome to the print formatting lecture. In this lecture, we're going to cover the various ways to format your print statements. As always, there's a full Jupyter Notebook that goes along everything we're going to cover. So we'll be covering the various formats of strings in Python 2 and Python 3. We'll also go over floating point number syntax. We'll look at some conversion format methods. We'll look at multiple formats, and then we'll look at the string.format method, which is probably the best way to use print formatting in Python. Okay, so let's go ahead and get started with some live code. First thing we're going to do is what we just covered in the string lecture, which is just a basic print statement. Again, remember, this is for Python 2. So I'm going to say this is a string. If you're using Python 3, this would be a print function, which we covered in the last lecture. Continuing on, let's say we had a variable that we wanted to insert into this string. So I'm going to make a variable called s, and it will be called string. And now what I want to do is place that string within another string, or really place that variable. So I'm going to say print place my variable here. And the syntax looks like this. It's going to be %s, %, parentheses, and then the object variable label. So if I click Shift Enter here, it's inserted that string variable into my other string. And I want you to notice here, I could have named this variable anything. So I could have said x here, and as long as it matches up x, it'll still work. What this S stands for is string. So what this is actually doing, it's transforming whatever object you have in these parentheses in front of the % into a string so it can place it in the string. And because it's transforming it into a string, I can actually put in numbers here as well. And if I run this cell, you'll notice it still works. And it's the same with floating point numbers. So for instance, 13.13, if I run it, it takes 13.13 here as x and transforms it into a string that I can put and format into my string before I print it. Okay, so that's one method of putting your variables into your string. Let's go ahead and check another one that's more specific to floating point numbers. So I'm going to say print floating point number colon, and the format's going to look something like this. It's going to have that same %, but it's going to have two numbers with a decimal in between. So I'm going to say 1.2 and then an F for floating point number. And then we'll close off that string with a single quote. And here we'll pass in a floating point number. So let's say 13.145. All right, so let's take a look at what happens. So if you notice here, it got cut off to 13.14. So why is that? If we notice these two numbers here, the first number is the total minimum number of digits that this string should contain. And I'll make that clear in just a second by enlarging that number. But what we want to focus on right now is the number that comes after the decimal. So this placeholder number stands for how many numbers to show past that decimal point. So if I were to change this to 3, it will show 145 when I run this cell. And likewise, if I change it to 1, it will only show one number when I print that cell. Now if I make it a very large number, such as 10, it's going to fill in the rest of those numbers with zeros. So again, this number after the decimal point tells you, or tells Python, how many digits will I show past that decimal point if it's a floating point number. Let's go ahead and remain it with 3, or have it stay with 3. Now, this first number is the total minimum number of digits that the string should contain. At least that's the way you can think about it. So if I put 1, nothing's going to change. But let's say I put in a very large number, such as 25, and click enter. Notice how we fill in a bunch of white space. So since you're telling Python, I need this entire digit here to take up 25 essentially characters, it's going to fill in the characters that are not there with white space. So you can go ahead and just arbitrarily leave this as 1 if you're not really concerned about your print formatting for floating point numbers. If we hop back over to the Jupyter Notebook, I've put in quite a few examples for you to really get an idea of how this affects your print statements. Okay, let's go ahead and move on to conversion format methods, which we've actually already seen one. So these two methods will just convert any Python object into a string. So the first one that we have already seen is convert to string, and that's just that %s. And then what I will do is just pass in any object, such as an integer, and it converts it into a string. The other formatting tool we can use is %r, and it will actually do the same thing. But the difference between them is they use two separate methods. One uses something called str function, and the other one uses this repr function. So don't worry about those specific functions right now. We'll learn about them later on and how those two separate methods are different. But I just want you to be aware of R and S as print formatting options. Okay, so let's say you wanted to put in more than one variable into your string. How would you do that? Well, you can use multiple percentage signs. So I can say print, let's say first, %s, second, %s, and then third, %s, and then I will finally call a percentage sign, and here have parentheses. And what I'm going to do now is pass in objects in the order I want them to show up. And this is something that we're going to look into further in just a tiny second. So if I say hi as my first object, and I'll have this one say 2, and this one just pass in a number 3, and I run that cell, what Python's going to do is it's going to take them in order. So this first percentage sign is going to be assigned the first item in this, which is a tuple, which we actually learn about in later on. And then the second one takes in 2 in order, the third percentage sign s takes in 3, converts it into a string, and then places it and formats it into your string. This is kind of a classic method that you see used a lot when you're reading other people's code, but the best Pythonic way to do this is using the string.format method. And I'll show you why. So let's say we wanted to print first, seconds, %s. Now, if I actually wanted the same object to go to both of them, I'd have to write it out twice, something like this, in order to make sure the code doesn't have any errors. But with the format method, it's actually a lot cleaner, and I'll show you why. So I can say print first, and I'm going to use curly brackets here, and I'm going to put in some arbitrary variable label, and you'll see why in just a second. And then I'm going to say seconds, and again, I actually will put in the same label. Close off my string, immediately afterwards, put in a period, and call the format method on that string. And then I will pass in the variable x, which let's say I wanted it to be a string called inserted. And notice here, I only have to define this variable once for it to get inserted multiple times. And this sort of syntax is really powerful in case you want to mess around with the order. So let's make another variable here called y, which we'll call just 2 exclamation point, so it's really clear where it is. And what I'm going to do is now change this to third, put in second in the middle, curly brackets y, curly brackets. So notice the syntax here. I put in curly brackets and then the variable name. And then the dot format, I just define what each variable is. And now if I run this, you'll notice I get first, inserted, second to third inserted. So this is really nice since I don't have to worry about everything being in the right order anymore. I just have to worry about the variables having the correct names when I call them. And this is really the way you should be print formatting as you go along throughout this course. It's the more Pythonic way of doing things. Okay, so that's the basics of string formatting. And just to remind you, Python 3 uses the print function, not the print statement. So I've already shown you how we can change that with an import method. So let's go ahead and bring it out here. So I'm going to say from, future, from future imports print function. And if I call that, now I can say print some string, hello, it prints. So this would be the case if you're using Python 3. Now again, I'm using Python 2 here, so I had to do this import statement. And we'll learn about import modules further on in the course, even though we've already covered them a bit in the last lecture. Alright, so what if I wanted to do the same formatting? It would be pretty much the same, just within the context of that function. So I would say 1 x dot format colon x inserts, just some strings so that it's really obvious. Close off my parentheses, make sure they all match, enter, and there you have it. So this is what it would look like if you're using Python 3. Again, in case you're confused about prints functions in Python 2 versus Python 3, make sure you go back and visit the string lecture where we cover the differences between both of them. Okay, so let's do a quick overview of what we learned, and let's hop back over to the Jupyter Notebook. So in this lecture we covered print formatting. We saw how we can format with strings using the %s notation and syntax. Remember, this %s will just format strings into your print statements by converting any object type into a string. We also saw the specific syntax for floating point numbers if we wanted to declare exactly how many numbers we wanted or how many characters we wanted, either after the decimal point or just in total. Remember, white space will be filled if you don't have enough characters in that floating point number. Then we looked at two conversion format methods, %s and %r, that actually convert any Python object into two separate methods. We looked at multiple formatting using this syntax. And then finally we learned about the dot format method for strings, which allows us to just define variables, and here you can see more examples in the Jupyter Notebook about that. But what's nice about this is we only have to worry about calling the variable names inside these curly brackets instead of maintaining the order as we did in that previous % method. Okay, so that's it as far as